Special triangles. Compare perimeter and area. Given that the shortest side of the 30, 60, 90 degrees triangle is equal in length to the shortest side of 45, 45 degrees and 90 degrees triangle, what is the ratio of their perimeters and area? Right? So these are two separate questions. The question is, what is the ratio of perimeters of 30, 60, 90 degrees and 45, 45, 90 degrees triangle with the same shortest side? And the second one is ratio of their areas, correct? So these are the two problems which we are going to solve. And we are going to use special triangles, correct? Now let me draw the two special triangles. The first one is 30, 60, 90. So let us say this is my 30, 60, 90 triangle. And then the second one is 45 degrees. So we'll have this one as a 45 degree triangle. Okay, so I've kind of drawn the triangles with almost same shortest side. So let us say that this side is A for both, since the length of shortest side is same for the two triangles, right? Now this is 45 degrees. That one is 90. This one is 60 degrees, and then we have 30 degrees. And this one, of course, is 45. So these two sides are equal. So therefore, for 45 degrees, the sides will be AA and square root 2 times A, correct? So we can write square root 2 times A. Now in 30, 60, 90, we know this is A, this is 2 times A. So I'll write 2A, and this side is square root 3 of A. That is how the special triangles are. Now we don't really have to do Pythagorean theorem to figure out what the sides are, right? We just know it, correct? So we'll start from here. So those of you who have problem understanding this, now they can look into my video where we are talking about the special triangles themselves, okay? Now let's proceed with the question. It says, given that the shortest side of 30 degrees, 60 degrees, 90 degrees triangle is equal in length to the shortest side of 45, 45, 90 degree triangle, what is the ratio of their perimeters? So that means we'll just compare ratios of 30, 60, 90 with that of 45, 45, 90 degrees, right? So let's compare perimeters first. So we do perimeter for, let us say, the triangle with 30, 60, 90. So we'll say perimeter for 30 degrees, 60 degrees, 90 degrees over perimeter of 45 degrees, 45 degrees, 90 degrees, right? Let's do that. So as you can see, what is the perimeter of these? Perimeter is the sum of these three sides, right? It is A plus 2A plus square root 3A. So that's what we get, A plus 2A plus square root 3A, right? And for the 45 degrees, we get A plus A square root 2. So that is the ratio of their perimeters when the shortest side is same, which you can simplify. So A plus 2A, A's are common, so we can cancel out A's, right? And then we get numbers, which is 1 plus 2 is 3, 3 plus square root 3. So we get 3 plus square root 3 in the numerator, and 2 plus square root 2 in the denominator. So that's an interesting number. Let's leave it like that. So at times you may be asked to find it to decimal places, right? Maybe hundredth of a decimal place. In that case, use your calculator to find the answer. At times you may have to rationalize this, since we have 2 plus square root 2 in the denominator. In that case, you need to rationalize it. So it really depends on question to question, correct? So we have done part A of the question, which is comparing perimeters. Is that okay? Now let's do comparison of areas. So this time I'll write area of triangle 30, 60, 90 over area of triangle 45 degrees, 45 degrees, 90 degrees. So what is area equals to? area you know is half base into height, correct? So let's write here. So area is half base into height. So half of base is same for both a, and height for 360 is square root 3 times a, and for 45 degrees it is half base is a, which is same, and height is also a, right? So if you compare this, half and half cancels out, right? So you can simplify this. Half and half cancels out, a and a cancels out, right? And this a also cancels out. So you are left with square root 3. So ratios of their height basically. So that is what you get. So what you find from here, that if you're comparing these two triangles, then their radius are ratios of their height, correct? And this is very interesting. 3 plus square root 3 over 2 plus square root 2 as the ratio of their perimeters. Now what we are trying to do with this is getting conversant with our special triangles, right? So just whenever you do trigonometry, I'll appreciate just draw these two triangles first and then do the rest of the questions which involve exact values. So, and now let's move forward. We've understood areas and perimeters for this triangle. Let's move forward and do some questions with different types of shapes involving these special angles. Thank you.